Okay, so it's recording now. Let's continue where we left off last time. We're doing it. Okay. Okay. Okay, so we did the ratio test last time, and then we'll continue with that. So we're doing an example. I hope I still have it. So what we had to do, we had to check. Anybody remember the last example? Was it k factorial over k to the n? N factorial over sigma n equal 1 to infinity, n factorial over n to the n. Right? Conversion. Okay, so we try, let's say, n be n factorial over n to the n. I try the ratio test, an plus 1 over a to the n over an. The absolute value here, the absolute value don't matter because I have positive terms, right? Okay, so could we stop the whispering? Whoever is whispering, please stop. Okay? Great. So an plus 1, n plus 1 factorial, n plus 1 to the n plus 1, n to the n. What do I have here? I have n factorial. What happens here? How do I deal with this? Yeah?
You turn n plus 1 factorial into n plus 1 times n factorial.
Very good. Very good, thank you. I'll just combine these, I guess. So far so good here. So as your friend said, I can cancel these out. What do I have left? N plus 1. And here what do I have?
N factorial.
Yeah. Okay. Did I make a mistake somewhere? Yeah, so I have something wrong, right? So I have at the end, I have something missing. What do I have missing? Right? Are we good here? Are we good? Are we following? What happens to the n plus 1? Goes away. What am I left with? N over n plus 1 to the n. Are we following? Clear? Great. Now what do I need? I need to evaluate the limit of this thing. So let me plug in. So n over n plus 1 as n goes to infinity goes to 1. 1 to the infinity, what is that? I'm in determinate form, right? So how do I do this? How do I find this limit? Now it might be a bit tough, but let us remember a fact. Let us remember this. Well, so what is this limit? Anybody can see that? So this limit is what is this limit? Can you see that it's 1 over e? Can you see that it's 1 over e? No? So let me write it this way. To the power minus 1, right? Can I do that?
Yeah.
Yeah, and let me to the power minus 1. What is the limit of the term inside? What is the limit of the term inside? 1 plus 1 over x to the x as x goes to infinity. What is that?
1.
This is e, right? Yeah? You remember this? Calculus 1? The power minus 1, which is e to the minus 1. Okay? Now is e to the minus 1 less than 1? E is strictly bigger than 1, so e to the minus 1 is strictly less than 1 by the ratio test. Sum n equal 1 to infinity. What is it? N factorial converges. Does it converge absolutely or not? Why? Because the terms are positive. Okay? So this is and you're here needless to say because the terms are already positive. Any questions on this? Any questions? Okay, I assume you have seen the fact that 1 plus 1 over x to the x goes to e, right? You have seen that? How do you do that? You have 1 to the infinity, it's an indeterminate form. You take the log, right? So you get x log 1 plus 1 over x, yeah? And then you put the x down, I think you get ln 1 plus 1 over x over 1 over x, and then you apply L'Hopital's rule. Yeah, you remember this? This is how you do it, I think, to my memory. Okay, great. And all of this should be reviewed, okay? So far there is nothing new. Now, let's move on to the root test. I think you've seen the root test as well. Root test. Anyone can help me with the root test? What does it state? You've seen the root test before? Yeah, what does it state? So if I want to check that, consider sigma n equal 1 plus infinity an, and suppose that lim as n goes to infinity an nth root of the absolute value of an. This is just an to the 1 over n, right? Yes? You know this? Nth root is just an to the 1 over n. Is equal to L, where L is bigger or equal to 0, possibly infinite. What could I say? How can I break the case? Anybody can help? Anyone? Any volunteer? Any volunteer? You don't remember? This was 2 weeks ago. I don't know how many weeks. Yes?
If it's inferior to 1, it's convergent. If it's superior to 1, it's divergent. And if it's equal to 1, it's inconclusive.
Very good. Then, if 0 and 1, then sigma n equal 1 to infinity an converges. And how does it converge? Absolutely. So it converges, right? It converges absolutely and it converges. If n is strictly bigger than 1, what could I say about this? Diverges, right? Agree? So if this sum diverges, if this series diverges, can I say that the series of the absolute value diverges as well or not? I can say if this series diverges, can I say that the series of the absolute value diverge as well or not? I can say that, right? Because if the series of absolute value were to converge, then this series would converge as well, right? Absolute convergence implies convergence. And if L is equal to 1, the test is inconclusive. Okay? This is still things you've seen last term. So we can do an example. Let's do an example. I just give you the series, and you tell me whether it converges or diverges, and you have to tell me what test we are using. Okay, great. Let's give an example. So what's a good thing to try here? What's a good thing to try? The root test, very good. So what is my an? My an is 1 plus 1 over n to the n squared. I take the nth root of that, I get 1 plus 1 over n to the n. I take the limit of this as n goes to infinity, and what do I get? E. Is e bigger than 1 or smaller than 1 or equal to 1? Bigger than 1. So what can I say about this series? Divergent. Very good. Let an. Of course, an is positive. Absolute value of an to the power 1 over n is just, right? Is equal to e, strictly bigger than 1. So, sum n equal 1, infinity, diverges by the root test. Okay, great. You've seen examples like that in calculus 2, okay? Yeah, everybody, I assume you're familiar with this stuff. If not, please practice more. Okay, great. Enough now with the root test. Let's do examples. On the midterm, you'll get a question like that. Okay, on the midterm? The question that I'm going to ask right now, you'll get exactly the same wording. Okay? What is the question? For each of the following series, say whether it's absolutely convergent, conditionally convergent, or divergent. Okay? You're going to get a question like that on the midterm. Now, how many series, I don't know. But it's definitely going to be something very reasonable. For each of the following series, state whether it is absolutely convergent, conditionally convergent, or divergent. Of course, you have to show your work. Okay. You actually can read this on the board. Yeah, okay. Yeah. Okay, let's start with the first example. I'm taking examples from Stewart now, okay? So if you have Stewart, you will find them. Let's start with something easy. So, who volunteers to give me a number? Who wants to give me a number?
A number?
A number.
What do you mean?
Just a number. An integer. Positive. 4. Another number? 4. So what's another number?
7.
7. Okay. There's 7. Let's take to the end. Okay? What? Is there anything? Nothing? Okay. Great. 4n squared plus 1 over 7n squared over 2, 7n squared plus, guys, hey, 7n squared plus 2 to the n. How do I check whether this converges or diverges? whether this converges or diverges. What is a good test? Root test. All my terms are positive here, right? The top is positive, the bottom is positive. Let's say, or you can just say limit and then goes to infinity. 4n squared, absolute value. 4n squared plus 1 to the n. The power 1 over n. What is that? This is good. What is that equal to? What is that equal to immediately? 4 over 7. Very good. 4 over 7. What can I say about this series? Converges, absolutely, of course. So, yeah. Okay, let's do another one. Any questions? Don't hesitate to ask, okay? So I'm assuming this is review, that's why I'm going slightly fast. Well, I'm going a bit fast. What about this series? Converge, diverge, absolutely convergent, divergent, conditionally convergent. What can we say about this? Diverges. Very good. Anybody can help me why? Someone else can help me why? Can tell me why? Yes, sir?
If you move the n downwards and you produce the limit, that will not be equal to 0. So
Exactly. What would the limit be equal to?
1.
1. Very good. Divergent. Why is that? This is a quick one. Since the limit and then goes to infinity of n sine 1 over n which is equal to 1. Since the limit as x approaches 0 of sine x over x is equal to 1. Right? Awesome. So far so good? Any questions? No? Am I going fast? Is it fast? Yeah? Okay. Yes, sir.
Why do you write let and not
What did I write? What?
you write let before writing
Could you please raise your voice? Guys, here, please. Yes.
I don't understand why you write let since you are not
Oh, okay, thanks. Yeah, I have to write let a n be equal to that, but I just did this immediately. Thanks. Thank you. Yeah. Okay. Let's do one more. Well, let's do a few more actually. We have like 10 or 15 more. Well, 7 or 8 more. Yes.
So solving this one requires knowing exact special limits.
Yes.
Are there like a certain list of special limits you would?
Guys, please, like seriously, I said if someone's speaking, please, I would appreciate that you listen to them. Yes.
Is there a certain list of special limits that you recommend us go over?
Everything is calc.
Okay.
Okay. I mean, here you don't need to know this, right? So how you do it in calc 1? You set x equal 1 over n, right? Something like that. This is how you do it, right?
Right.
Suppose
But you have to remember the special limit though.
No, you can do it with L'Hopital, for example. Even though it's circular reasoning.
Okay.
Sine x over x, 0 over 0, right?
No, yeah, it's just L'Hopital is not valid here because of circular reasoning.
Yeah,
But-
exactly. But I mean, all you care about is remember.
Yeah, sure, yeah.
Okay. Because to prove the derivative of sine x is cosine, you need this one. Right? Yeah. Okay, great. Let's do one more. This one, diverge or convergence. So how do you approach a problem like that? You can do it in many ways.
Can you try limit comparison?
You can try limit comparison, but sure, what you want to compare it with?
1 over n squared.
1 over n squared. So let's see the reasoning behind this. Why do I want to try a limit comparison with 1 over n squared? This is 1 over n squared, right? Now this term, when n is large, what is e to the 1 over n? It's e to the 0, right? What is e to the 0? 1. That's one reason. Great. Let's try to do another reasoning. E to the 1 over n. What's the largest value e to the 1 over n can take? So let's look. E. N equal 1, you get e. Right? N equal 2, what do you get? E to the 1 half. N equal 3. What is the largest of these? E. Right? So let's try by comparison, and then we can do it by limit comparison as well. So, of course, this is bigger than 0. Right? Agreed? So far so good? Since then by comparison, right? Comparison needs both of them to be positive, and one is bigger than the other. And you could also try a limit comparison. Converges absolutely. Okay. I mean here it's obvious because the terms are positive. Okay, so far so good? Let's do one more. Well, let's do a few more actually. Oh man, okay. Any questions? Please ask. Don't hesitate to ask. Yes? Oh, you have a question. You did things like that before in Calc 1, in Calc 2? You did? Or not that difficult? Yeah, I think you did things of this difficult, yeah. I think so. Okay? Now let's look at this one. Converges or diverges? So, diverges. Very good. Why? It fails the alternating series test. So the alternating series test is not an if and only if. Okay? The alternating series test is one way. Right? Now, but you said first that let's check the limit. Is the limit of this thing 0? What is the limit of the term inside? Yeah? Well, so take n to be odd. Okay? Take n to be odd. along odd numbers of n. So this cos 1 over n squared goes to 1. Agree? Everybody agrees? If n is infinite, 1 over infinity is 0, cos of 0 is 1. Now take n to be odd. What's this limit? Minus 1, right? If you take along odd n's, you get minus 1. Now if you take along even n's, what do you get? 1. So does this limit exist? Exactly. So this limit does not exist. And we can do it in a faster way. What is the limit of this in absolute value? This is just this, right? Which is 1. Now if this were to have a 0 limit, what would the limit of the absolute value be? If this sequence has a limit of 0, what would the limit of the absolute value be? 0. Is the limit of the absolute value 0? No. So does this have limit 0? Okay. And not 0. And in fact, does not exist. In fact,
Not
exists. So minus 1 over n cos 1 over n squared. Okay. So far so good? So far so good. Any questions? Any questions? Please don't hesitate to ask. It's important. Yes.
Yeah, so why can't you use the alternating series test?
So the alternating series test. So the alternating series test tells you when it converges. It tells you if you have these two things, then it converges.
Okay.
Right?
Okay.
It's not an if and only. It's not an if and only if. Okay, you need to have it decreasing and converging to 0. If you have these two conditions, then the series goes to 0. Then the series converges.
Okay.
The other way doesn't go. I mean, yeah, it doesn't go. You know, usually. Okay. So please don't try to make up your own theorems. Okay, this is the most important thing, that you don't try to invent your own theorems. Let's do Are we good here? Should we do more example or that's fine? That's fine? Do you guys need more examples? Slightly harder examples or is good? Up to you. What do you want? A bit harder, a bit easier? Yes?
What test did you end up with?
Here?
Yeah.
Just the limit test.
Okay.
Like it doesn't converge to 0, so the series diverges. The very first test. What do you call divergence test? Divergence test, yeah. Okay, is it clear here? Is it clear? This is nice review. If you think that this is not familiar, I re-invite you to, I re-invite you to practice, or maybe see if this course is adequate, to. We're gonna need a lot of prereqs, okay? And so yeah. Okay? Any questions here? Yes.
Wait, so the limit isn't 0.
Limit isn't 0.
Isn't it always going to diverge because then you take the absolute value?
Exactly. The limit of this, which one? This one?
Yeah.
Yes. Isn't 0. you have an positive and decreasing to 0, then you can say that the series converges. But it doesn't tell you if, it doesn't tell you the converse. Right? So here we're saying, okay, if my an doesn't go to 0, then, well, if an doesn't go to 0, then yes, but it's not the alternate series test. Right? This is just the divergence test. Okay? Just look at the limits. If it's non-zero, then it diverges. That's it. Okay. Well, let's do one more, and then start something new. I think this was like 1 month of calculus 2, right? But we're covering it quickly, so that I mean, why am I going fast for one reason is that the end will get tougher. So usually at the end it's very the time is very tight, and then we'll try to go faster on the hard stuff, on the new stuff. I prefer to go slower on the new stuff and faster on the stuff you have seen before. Okay, what about this?
Separate the one.
Very good.
Telescoping series.
Awesome. That's right. Did you see this before? It's a telescoping series. Right? If I just write right? So plug in here, start with n equal 1, what do you get? You get log 1/2 minus, well, let's do it this way actually. You get log 1 minus log 2 plus log 2 minus log 3 and so on, right? Isn't that right? Does this diverge or converge? You cancel the log 2, right? What are you left with? You're left with the log 3. So you're left with log 1 minus, if you truncate the sum at index k, say, you're left with log 1 minus log k. If k goes to infinity, what happens to this series? It diverges, right? So here let's truncate the sum. Log k is equal to the first term, log 1 right? You're left with log n plus 1. Sorry, yeah. Okay? Which is just minus log n plus 1. And then goes to infinity. Where does this go? To negative infinity. Minus log. So okay. Any questions on this? Yes, sir.
Can you not try divergence test from the beginning?
Divergence test. So limit as n goes to infinity, n over n plus 1 is 1. Ln of 1 is 0. Okay? But yeah, that's the first thing you should look at. Always check whether the limit is 0. Okay? Say for example I had a 2 here. 2n over n plus 1. Immediately you can say it diverges. Okay, great. Any questions on series? Any questions? Great. I hope this was a good review. before I raise any questions on this, one last time. I assume it's all good? Great. Now we'll start we'll review another topic that's going to be important for us. Power series. Okay? This is stuff you were supposed to have seen in Calculus. We'll just review it. And we'll start with a small example. How to motivate this with a small example. Now, what is that equal to?
One over one minus x.
1 over 1 minus x. Is that correct, or I missed something? Did I miss something?
If x in absolute value is less than or equal to
Us.
sorry.
That's less or equal, but strictly less than. Okay, so really, this series defines a function of x, right? If x is between -1 and 1, strictly. You agree or not? You can plug in 3/4. If you plug in 3/4, what do you get? You get 1 over 1 minus 3/4, so you get 4. Right? This series converges if the absolute value of x is less than 1. And hence defines a function that is equal to this function. You agree? You can plug in numbers, several values of x, and you get a finite number. Provided this x has absolute value strictly less than 1. So this gives you a function. Right? That's it. Is it clear or not? Is it clear? That gives you a function. Now, does this give a well-defined function if x is strictly bigger than 1 or not? If x is strictly bigger than 1, what could I say about this series? Divergence, right? If x is strictly smaller than 1, if x is strictly smaller than -1, what could I say? It also diverges. Now, what if x is equal to 1? Does it converge or does it diverge? It diverges. And what about x equal to -1? Diverges. So for what values of x does this series converge? Does this series converge?
Exclusive from -1 to 1.
Exactly. The series converges. Do you know what if and only if is? Have you seen if and only if? One way and the other, right? If and only if x belongs to -1. Agreed? What is -1 called? What did we call -1 in calculus 2? The interval of convergence, right? -1 is called the interval of convergence of what is the radius of convergence in this case? the center of this interval is 0. What is the radius of convergence? Is 1. Okay, very good. Okay. Let's review some examples. Let's review some nice examples. Is this familiar or not? Yeah? Is this familiar? Yes or no?
Could you repeat the radius of convergence again?
The radius of convergence. What is the center of this interval? 0. What's the distance from 0 to the endpoints? 1. So this was not C. Okay. Power Taylor series, okay, but even this. Okay. How many of you have not seen this in Cat 2? Still a good proportion. Okay, so I'll try to go. I mean, is this thing clear here? Is this thing clear? That's what I want. If this is clear, then we can proceed and do some exercises by example. Let's see. Find the radius and interval of convergence of. So I'll pick something nice. Should I pick something nice? Let's pick something nice. What does it mean? What does this question mean? Find the interval and radius of convergence. You can summarize it in one small line. For which values of x does this series converge? Okay? If I ask you for which values of x does this series converge? How do you proceed about that? How do you proceed in tackling this question? Yeah?
You use one of the tests, and then depending on the value of x that will cause it to converge, you can then conclude.
Exactly. That's it, right? You see that? So, what then? Yes.
Sorry, I did have a question actually.
Yes.
This is also applicable to before, but are the tests only? We've only seen series so far, where n starts at 1, but sometimes n starts at 0. So does this also? It doesn't matter.
Because you're looking at for large values of n, right?
Okay.
You're looking series. It doesn't, like the first three terms don't matter. Okay. So, how do I try? So how do I approach this problem? What is an plus 1 over an? A absolute value, of course. This is absolute value of x with the n plus 1 over 2 n plus 2 minus 1, so it's 2n plus 1 over 2n minus 1. So what is that? This is just what do I have here? Just a second, sorry. Let's see pretty clear immediately. Let me just put the absolute value here. So what do I get? I get 2n minus 1 over 2n plus 1 times x. Agree or not? So far so good? So far so good? For which values of x does this converge? So I take the ratio test. Now if I want this to converge, what do I really want? Yes?
The limit should be less than one.
The limit to be strictly less than 1. So what is the limit of this thing here? Two n minus 1 over 2n plus 1, where does it go? 1. 1 times absolute value of x, what do I get? Absolute value of x. So for which value does this series converges? If absolute value of x is strictly less than 1. Now if the absolute value of x is strictly bigger than 1, what can I say about this series? Diverges. Because of the ratio test. Yes? So, this limit is absolute value of x. So if x is strictly less than 1, converges. And how is the convergence? What can I? Absolutely. If x is bigger than 1, then did I start at 1 or at 0? I think I started at 1, right? Started at 1 or at 0? Where did I put 1? Yeah. So far so good? Is it clear? Now what am I left with? If the limit is equal to 1, what can I say? Does the ratio test give me something? Doesn't give me anything, does it? What can I say about it? The ratio test is inconclusive. But really, I can figure this out, right? So what is absolute value of x is less than 1? What is this interval? Negative 1, 1. So the series converges absolutely if x belongs to minus 1, 1, and the series diverges if x agree or not? Now what do I have to check? The ratio test tells me that if the limit is strictly less than 1, then it converges. If the limit is strictly bigger than 1, then it diverges. What do I have to check?
Limit at 1.
If the limit is equal to 1, right? So what is the limit? It's absolute value of x. If absolute value of x is equal to 1, what can I say about x? It's equal to minus 1 or 1. So you found an interval like that. This is how you did it, right? You found an interval like that, and then you have to check if it converges at the endpoints. You agree or not? Now check the endpoints of this interval. For x equal 1, what is the series? It is sum n equal 1 to plus infinity 1 over 2n minus 1. Does it converge or does it diverge? Why? P series, right? Almost P series, right? What can you compare it with? You can compare it with 1 over n. Limit comparison. Well, I mean, you can still, yeah, so but limit comparison is less or equal to 2n. Agree or not? And this is bigger or equal to 0. So 1 over 2n agree? This one here diverges. So this one will diverge. By comparison. I don't know why it's not right here, but anyways. Well, I mean, let me write for x equal minus 1 here. For x equal minus 1, what do I get? What is my series if x is equal to minus 1? This is my series. Agree or not? Just plug in x equal minus 1. What do you get? This series, right or no? Does it converge or does it diverge? Convergent. Is it convergent or divergent, everybody? Convergent or divergent? Someone else? Someone else? Someone who hasn't spoken today? Yes, sir.
Alternating series then?
Very good. Why can I apply the alternating series test? Anyone can help? Someone else? Someone else? Someone who hasn't spoken today? Why can I apply the alternating series test?
Because 1 over 2 n minus 1 is completely unworkable.
And? Goes to? 0. Okay? Very good. 1 over 2n minus 1 is positive and decreases to 0. So converges by the alternating series test. Please on your exam write the full thing, okay? Here I did not do it for the lack of space. So what is the interval of convergence of this series? For what values of x does it converge? So it converges if x is strictly between minus 1 and 1, right? Does it converge for x equal minus 1? Does it converge for x equal 1? No. So what is the interval of convergence of this series? Minus 1, 1. Where do I open my brackets and where do I close my brackets? So the interval of convergence of okay, so I have minus 1 and I have 1. In minus 1 do I include minus 1 or not? Yes. Do I include 1? No. Very good. That's it. Okay? What is the radius of convergence in this case? 1. Okay? The radius of convergence, usually you can find it, when you look at the limit and you set the limit less or equal to 1, you can find the radius here. So, but I mean, you can still find it here. What is the midpoint of minus 1 and 1? 0, right? So what is the distance of this interval? This is 2. Divide by 2. 1. Radius r is 1. Okay, great. This should be review as well, so I don't think it should be that new. So should we do more tougher questions? We do tougher ones? Let's do tougher questions. I'll do one more. For which values of x does, let's see, Any questions? So do you want me to pass by, give you 2 minutes to try this, and then I'll pass by? Okay, so take 2 minutes, try it. It's not 2 minutes to speak, to talk. It's 2 minutes to try, okay? If you have questions, I will pass. Raise your hand and I will come to your desk. Where did I stop? Oh, thank you very much. So for example, a question like that is fair on the midterm. Okay? The midterm is just going to be a test whether you attended class and did the homework. So it's going to be something very straightforward. Study, repeat the examples of class, do the tutorial questions, and you should be fine. Do the workbooks and you should be fine. Okay? And it's happening on Tuesday, right? Tuesday 20th? Yeah, yeah. I put an announcement, right? Yeah, okay. So how do we try that? How do you find this? What's the way to go? Say? Yeah? Someone? Someone said this? Ratio test, right? So let AN, I mean some people write AN of X, you can write whatever you want as long as it makes sense. So AN plus 1 over AN. What do I get? I get X minus 2 in absolute value to the N plus 1 over 2 to the N plus 1 log N plus 1 times 2 to the N log N over absolute value of X minus 2 to the N. Took, cancel stuff. What do I get? X minus 2, right? Over 2 log N over log N plus 1. Yeah? What do I want? I want this to have a limit. What should the limit be for it to converges? For sure. If the limit is strictly less than 1, right? Are we good? Now what is the limit of this thing? I have an X minus 2 over 2, very good, in absolute value. And then I have the limit of log N over log N plus 1. What is this limit? What is it? 1. Very good. Why is it 1? That was true. Very good. Following? Are we good? The limit as n goes to infinity of an plus 1 put the x minus plus 1 on top. Okay? Great. So, for what values I'm sure that this series converge? Oops, this is from the previous question. So, for what values am I sure that this series converges? What should the limit satisfy? It's strictly less than 1. So, if x minus 2, this is this limit, right? Where is it? X minus 2 over 2, strictly less than 1. Converges. Absolutely. Diverges. So far so good. So far so good. Yes, sir. Where? Here?
No, divergent.
Divergent. Okay. And now how do I write x minus 2 over 2 strictly less than 1? This is equivalent to x minus 2 is strictly less than 2. What is the radius of convergence here? You can read it up immediately. The radius is 2. Okay? Yeah? So this is equivalent to what? To minus 2. X minus 2 or 2. This is equivalent to x is between 0 and 4. So I'm sure that my series converge inside the interval 0, 4 without the endpoints. What do I have to check? The endpoints. So what is my first endpoint? 0. So if x is equal to 0, what is my series equal to? My series is equal to what? 1 over? No, if x is equal to 0. 0, so if x is equal to 0, 0 minus 2, what do I get? Minus 2 to the n, right? Great. What can I do now? I can cancel the ends. What am I left with? Okay, this is a bit fun. This is maybe nice. So far so good. So far so good. Any questions on how I got this? Should be clear, right? Here? Yeah. Now, what can I apply here? What test can I apply? I can apply the alternating series test. So before we apply the alternating series test, what do I have to make sure? I have to make sure that the conditions hold. Exactly. So 1 over log n, is it positive? If n is bigger than 2, bigger or equal to 2, log n is positive. So 1 over log n is positive. Are we good? Great. Is 1 over log n decreasing? Yeah, why is it decreasing? Because log n is increasing and positive, so 1 over log n is decreasing. Right? Agree or not? Great. Does it go to 0? It goes to 0. So by the alternating series test, this series converges. Okay? Are we good? Let's write this down. So for obvious things like that, 1 over log n, you can tell me it's positive and decreasing without trying to convince me. I can trust you that you know that 1 over log x is decreasing on say 2 to infinity. Okay? You can just state it, and I'll trust you on that. And you can say it's positive. Okay, so don't hesitate to assume full knowledge of calculus 1 because I think the goal is not to take many derivatives, right? Okay, so 1 over log n is positive and decreasing with limit is equal to 0. So by the alternating series test, converges. Okay, now what do I have to plug in? What are my two endpoints? 0 and 4. When I plug in 4, what do I get? When you plug in 4, so 4 minus 2 to the n, right? For x is equal to 4. What is my series? It's a sum n equal to 2 plus infinity. 4 minus 2 to the n over 2 to the n log n. What do you get? 2 to the n over 2 to the n, what happens? 1 over log n. Now, does this converge or does it diverge? Diverge. Why? Compare it to 1 over n. Very good. We've seen that log n is less than n, right? Log x is less than x. If x is bigger than 2. If x is bigger than 2, say log x is less than x, right? You've seen this? Yeah? You've seen this or no? Yeah? Okay, I mean, I'll leave you the details of this. I'll let you the details and you can try it, okay? So the answer is that diverges. Diverges. Compare log n to n. Okay? So log n is less than n, right? So when you take 1 over, it flips. Okay, so the series of 1 over n diverges. So log n the series of 1 over log n will also diverge. Okay? Again, this is calculus 2, so I'm assuming you're fully comfortable and easy. You can do this with ease. Okay? So what is the interval of convergence of this one? What I have, x minus 2 to the n has interval of convergence. What is it? 0, 4. Is 0 included? Is 4 included? Awesome. Easy work, isn't it? Any questions? Any questions? Okay. Should be familiar, I guess. What if it's not? I mean, we can do one more example. Do you want to do one more? We can do one more, but it's do you want to do one more? Should we do one more? Great. Let's pick an easy one here. Let's see, just a second. Actually, no, okay. So let's try this one. So what do I do? As usual, what do I do? Ratio test, right? How do I know? When you have things like that, it's usually ratio test. Okay? So whenever, it's a good question. It's a good question. How do we know how to use it? You haven't seen this in class 2? How do you know if you have used this? Usually whenever you have like geometric powers and ends, it's ratio test. For questions like that, usually it's ratio test. Okay? You can still do the root test sometime. But here, can you try the root test? You can try the root test. To give the same answer. Yes?
What's the easiest way to tell if you should use the root versus the ratio test?
Constant practice. Okay? Practice. The more you practice, the more you will see how. So if you take the root test, you will have to know n to the 1 over n. Right? What is the limit of n to the 1 over n as n goes to infinity? 1. Right? But if you do the ratio test, it's going to be easier. Okay? Again, this should be review. This should be review. So how do you do that? Ratio test. So let an plus 1 over an in absolute value. What is that equal to? This is just, so I can ignore the minus 1 to the n, right? Do you agree? Minus 1 to the n absolute value is 1. So what do I have? I have absolute value of x to the n plus 1 over n plus 1. 5 to the n plus 1. And n 5 to the n. This is x. I have over 5. And then I have n over n plus 1. What is this limit? As n goes to infinity. Are we good here? Yeah? What is this limit as x goes to infinity? N goes to infinity, n over n plus 1 goes to 1. So this limit as n goes to infinity is absolute value of x over 5. So what happens? What is the radius of convergence of this series? Can you tell me immediately? The radius of convergence? 5, right? This limit, yeah? This series. So if x the series converges and if x over 5 is strictly bigger than 1, it converges absolutely. Series diverges. What do I have to check now? So my interval of convergence will look like minus 5 and 5, right? What do I have to check? The endpoints. So if x is equal to minus 5, what do I get? Where am I? Yeah, so if x is equal to 5, does it converge or does it diverge? If x is equal to 5, does it converge or does it diverge? Immediately, just look at it. X is equal to 5. You cancel these two. You cancel. You get 5 to the n over 5 to the n. So you get minus 1 to the n over n. Does that converge? Does this series converge or diverge? Converge by the alternating series test. Now if x is equal to minus 5 to the n, what do you get? So put x is equal to minus 5. What do you have? You have on top minus 1 to the n, minus 1 to the n, they cancel out. So you get 1 over n. Right or no? Following? Yeah? Let's do it. I'll let you justify it. And if x is equal to minus 5, what do we get? Minus 5. So how do you do this? You have minus 1 to the n, right? And then you have minus 1 to the n here. They cancel out, right? Do you want to write this down or it's clear? Should I write this down? Okay. Minus 1 to the n times minus 1 to the n, what is that? This is 1. Which diverges. And then what can I say? What is the interval of convergence? It's minus 5, 5. Is 5 included or not? 5, is it included?
Yeah.
Is minus 5 included?
No.
Okay. Minus 5. 5. What is the radius of convergence? 5. Okay, so we're good, right? It's not that bad, is it? Is it bad? For those who haven't seen this before, is it that bad? It's okay? This is your first time seeing it, so if it's okay, then it's good. So with practice, you will just get better at this. Okay? Again, practice this. You're probably going to see a question like that on the exam. For which values of x does the series converge? I mean, yeah. So for now you know 2 questions. For each of the following series, state if they diverge, if they converge absolutely, conditionally or diverge. And another question will be, for which values of x does the series converge, and find the radius of convergence. Okay? Yeah. Yes. Yes. No. Not for the endpoint. Not for the endpoint. The endpoint. What's the absolute value? On this one. Sorry, not. Oh, you mean for x equal 5, what's the absolute value here? Does it converge absolutely? Here it converges absolutely. Inside the endpoint, it converges absolutely. But on the endpoint, it's not necessary. Okay? Good question. Very, very good question. Yeah, so your friend asked a question. Is the convergence here absolute at 5? What is the answer to that? No. Is it inside minus 5, 5? Inside this, is it absolute convergence? Why is that? By the ratio test. Okay? Or also the root test. The root test will give you the same answer, I think. Right? Okay. Any questions? Any questions? Is it clear? What time is it?
12.
1 hour and 30.
There's 1 hour left. Okay. Okay. I mean, let's write a theorem. Let it be a real number. For a series. Dn x minus a to the n. Right? Do you agree? I mean, I don't want to use, what do you want to use? an or cn? I think can't convert to Cn because usually I denote this whole thing by En. Okay? So your A is 2, for example, or your A is 0, right? So here, for example, your A was 0, right? You had x to the n. Okay? There are the following. There are only these cases. Well, only those possibilities can occur. Alright? Only one of these possibilities. One, the series converges. Only for x equals A. The series converges for any x and R. So the interval of convergence is R. We'll see an example right now. And 3, which is the case you've seen now, right? I'll give an example of these two things. 3, let me put 3 here. The series converge if x minus a strictly less than R. Well, or there exists an R. I mean, are you familiar with numbers like there exists and there is? Are you familiar with these things? There exists a positive number R.
Yeah.
There exists R strictly positive. Such that convergence if and diverges notice I did not talk about the endpoints because the endpoints have to be checked individually. Okay? So usually the intervals of convergence of a series like that is either one number, which is A. I'll give an example right now. Or the whole real numbers. It converges for every value of x. And 3, it converges on an interval of the form x minus a strictly less than R, and diverges if x minus a in absolute value is bigger than R. Now if x minus a in absolute value is equal to R, which are the endpoints of my interval, I have to check them individually. Okay? But it diverges otherwise. What is the radius of convergence in the third one? In the third case? The radius of convergence is R. In the second case, what is the radius of convergence? What is the radius of the whole real line? Infinite. In the first case, what is the radius of convergence? 0. What's an example where the series converge only for x equal a? For x equals 0, say. Very easy example. X over n. If x is equal, yeah, sure. Right? That's one example. Or you can just take x, sigma n equal, right? Or n times x, for example. Okay? Great. Well, the series for converges for any x in R, this can be a bit tricky to establish in some cases, but maybe we can try one. Well, yes, sir.
So, remind me, C sub n doesn't just have to be some series of constant
should be review. I hope you know you can. I will. I think the easy part is that this is easy to master once you practice a lot. Okay? So I'll make sure you get tons of bugword questions on this one. Make sure you have a busy weekend, I guess. And then, yeah. Okay, then you'll practice very well. Yes?
Theorem code?
I don't know. I don't know what you call it. Okay? I don't know what it's called actually. Just a theorem. But I mean, I won't ask you to state a theorem. Okay? I won't ask you to state any theorem. Except one theorem that I may ask you to state. It's called the implicit function theorem that we're going to see later. But this is the only theorem I'll ask you to state. If I ask you to state it. Anyways, okay? So these are the results. Now we can embark on something new, or we can do more review. What do you guys prefer? Review?
Review.
Okay. So we do exercises of these? Okay, so let's do that. Okay, so if you have questions on the stuff, please let me know so I can answer them. Let's see. Or you know what? We could do one more theorem. Okay? Do you want? I mean, it's an easy theorem. It's not hard. Okay? It's not hard. Now, I want to see how to do. Have you seen the word analytic or not? Yeah, that's okay. So we will not use it, I guess. Okay. This is a very nice theorem. You don't need to know the proof. It's as intuitive as it gets. Okay, as it gets. Suppose f of x is sigma n equals 0 plus infinity to Cn x. Okay? So I have a function f. Guys, hey, I know it's hard to stay focused for 2 hours, but yeah, I mean it's very hard even for me. So basically what I'm saying is that this series converges on this interval. Okay? Like this series converges on, what is this interval? Can you help me? This is just minus r plus a, right? R is a positive number. Okay? Then, how do you expect to differentiate f prime? How do you expect f is differentiable, right? If I tell you differentiate this infinite sum, how will you differentiate it? What is this? This is C0 plus C1 x minus 8 plus C2 x minus 8 squared, and so on. If I tell you differentiate f prime, differentiate f, what do you get f prime? What is the derivative of C0? 0. What's the derivative of C1 times x minus 8? C1, right? What's the derivative of C2 times x minus 8 squared? It's 2C2 times x minus 8. Differentiate this. With respect to x, what do you get? Yeah, just differentiate this term. You see, you guys see how to differentiate stuff? Yeah? It's easy, no? How do you differentiate this thing here? This infinite thing, how do you differentiate? Yeah, you bring the 2 down, right? These are just easy polynomials. Right? So f prime of x, f is differentiable on a minus r. It's weird that this is not seen in every calculus too, huh? So again, this fall, the fall you have seen it, but not the winter, right? The fall it was. Okay. The fall you have seen this, right? No? You haven't seen that you can differentiate the series?
We saw radius of convergence.
And you stop radius of convergence.
Yeah.
Okay. I see, so when I said radius of convergence, maybe 70% of the class was okay. Now when I said this, boom, nobody was good. Suppose you have this function, okay? Let's do this. I have f of x is equal, let's make it simple. C0 plus C1x plus C2x squared plus C3x cubed plus so on. In the most natural way, without worrying about anything. Differentiate f. How would you start? How would you differentiate? Say set a to be 0, just to be easy. How would you differentiate f? F prime is equal. What is f prime equal to? What's the derivative of C0 with respect to x? 0. What's the derivative of C1x with respect to x? Very good. Now you may say, okay, but this is obvious, right? Like, derivative of C2 x squared is 2C2 x plus 3 C3 x cubed. X squared, sorry. And so on. This theorem states that you can differentiate term by term. It may be an obvious theorem, but it's not so obvious. Because when you have the sum rule, if you know this, you know of derivatives. F plus g prime is equal to f prime plus g prime applies only for finitely many functions. Right? Here you're adding infinitely many functions. But again, this theorem says that you can just differentiate this up. And let me write this here. Is equal to sum n equal 1 plus infinity n in n. Okay? Are we clear here? Is it clear? Do you guys see this? Differentiate them. Differentiate C0, 0. Differentiate C1x minus a, what do you get? So what is the first term here? You get 1 times C1. For n equal 1, you get 0. For n equal 2, you get 2C2 less minus a, and so on. Okay? Yes?
And the example you just given before,
Yeah.
the one was like C1x, C2x squared,
Yes.
A
A is 0.
Oh.
Yeah. Okay? And what's the integral of f? And integral of f of x dx. You integrate term by term. Well, let me just put it like that. Do I have it this way? This way. Let's do an example. Okay? Very easy example. What is our favorite series? What is it? 1 over 1 minus x? Yeah. Right? Let's do an example. We have that 1 over 1 minus x okay. What do you guys want to do? Let's differentiate both sides. What do you get? Differentiate both sides. Differentiate d by dx. prime is minus 1, so it's 1 over 1 minus x squared. Agree or not? Are we good here? Yeah. This is d by dx. What is this? What is the derivative of this one? Derivative of 1 is what is it equal to? 0. Derivative of x, 1. Derivative of x squared, 2x. So let's write this one here. It's sum from n equal 1 to plus infinity, right? You drop the n down. Four. Easy, right? Is it clear or not? Okay. Is it clear? I can differentiate both sides. This is what the theorem tells me. Right? Yeah? Differentiate this side. Differentiate 1 over 1 minus x. You get this. Minus u prime, which is minus minus 1, over u squared. Good? This is good. Now I have to differentiate this one. What do you do? What is x to the 0? It's 1. Really, so you can ignore the n equals 0, and you start at n equals 1. At n equals 1. Differentiate x to the n, what do you get? You get n times x to the n minus 1. Is it clear? Everybody, is it clear? Yes.
Just to clarify, for however many derivatives or integrals, the radius of convergence will never change.
Will never change, exactly. Okay. Should we do one more? Is it clear here? Everybody, is it clear? Yes, sir.
What exactly is solving forces? Like, how do I get it?
Pardon me?
What exactly is solving forces? What is it?
Could you please?
What exactly is solving forces?
I'm just looking at if I differentiate both sides, what do I get?
Yes.
Yeah. So you're getting a power series of this function, basically. Okay? So starting with a power series of this function, you're getting a power series of this function. Of 1 over 1 minus x squared. Okay? So let's try to get a power series of log 1 minus x. Okay? Again, I'm going slightly fast because even though nobody, maybe not, most of you have not seen this, but this should have been seen. So, how do you start with this? 1 over 1 minus x. How do you get from 1 over 1 minus x to log 1 minus x? Say? Raise your voices? Integrate, right? Higher. Integrate, right? If you integrate 1 over 1 minus x, what do you get? You get minus log of 1 minus x. Agree or not? Integrate both sides. What do you get? Take the integral of both sides dx. It's equal to the integral plus the constant, right? Agreed? How do you integrate 1 over 1 minus x? Log of 1 minus x, right? I mean, here you have to be able to, you may have to be, no, that's good. This is minus log 1 minus x. then you put the integral inside, right? Is equal to, let's see. Oops. Let's see. So what do you get? You get minus log 1 minus x. X to the n plus 1 over n plus 1 plus c. Are we good here? Everybody, are we good? Is it clear? I'm just integrating. Straightforward integration. Now how do you find the value of c? How do you find the value of c? I plug in a value of x. But this value of x should be in the interval of, should satisfy x is strictly less than 1. What value of x do you want me to plug? What's the easiest value? 0, right? So if x is equal to 0, what do I get? I get minus ln 1 minus 0. If x is equal to 0, what is this equal to? 0. Plus c. So c is equal to what? Minus ln 1 is equal to 0 plus c. This implies that c is equal to 0. So minus is equal to sum n equals 0 plus infinity x to the n plus 1 over n plus 1. Now if I shift it again, what do I get? I can start at n equal 1 to plus infinity x to the n over n. So ln 1 minus x minus xn over n. Are we good here, folks? I don't know who does that actually. But anyways. Yep, I don't know if they do that. But if they don't do that, that's okay. You're still responsible for it.
There's a normal series 1 plus x.
Pardon me?
Maybe that's why.
Pardon me?
Maybe because the regular series is 1 and 1 plus x. So maybe that's why.
Oh, I'm talking about the whole chapter, not about this particular example. You mean, yeah, 1 plus x will be just have minus 1 at the end.
Right. That's not the normal power series we see from 1. Right. Normally you see 1
Oh,
plus
okay.
x.
Okay, I see.
I thought that's what you were referring to.
Oh, no. Yeah, I was referring to the whole idea of differentiating and integrating series. We do one more? We do one more? Let's do one more. Let's try to find the power series for, what's your favorite function? And why is it not arctan x? Let's try to find a series for arctan x. What is a good, how do you define arctan x? What's a nice way to define arctan x? Yes?
Integration of 1 over 1 plus x squared, so we can work with that idea.
Okay, so we can start by working with 1 over 1 plus x squared. Okay, great. Now the question is that how do I start by working with 1 over 1 plus x squared? Someone else? So we have a very good suggestion. If I want to find the series of arctan x, your friends notice that an antiderivative of arctan is one antiderivative of this thing. Right? Cot 2 or cot 1, I don't know. I mean both of them, right? This is cot 1. How do you do this? So the idea is that I start with a series of 1 plus By the way, these you have to memorize, okay? These you have to memorize. The ln and the arctan. Well, you don't have to memorize, but I can ask you. So I clearly don't have them memorized. I already write them every time. But for example, maybe we can do an example later. I can tell you what an example of questions would be. Okay, so how do I find the series of 1 over 1 plus x squared?
X over 2n.
Okay, we're starting to. So let's. So let's see. Let me write this actually. Right? Now your friends notice that if I put an a squared here, I can put an a squared here, and if a squared is less than 1 absolute value, if and only if a is less than 1 absolute value, so that won't change, right? But do you really need a 1 minus a or 1 plus a?
Oh,
1 plus a, okay? So do it this way, let's put it this way. So 1 over 1 plus a what is that? Oh, let's write it. 1 minus a, so I can really apply the 1 here. Minus a to the n. If the absolute value of minus a is strictly less than 1. Agree or not? Everybody, we agree? Everybody? Yes or no?
yes.
Great. Well, what is the absolute value of minus a? It's equal to the absolute value of a, right? So, this is equivalent to this. Okay. So now I have 1 plus a is equal to that. So 1 over 1 plus a is equal to sum n equals 0 to plus infinity minus 1 to the n a to the n if a is less than 1 in absolute value. So far so good, everybody? So far so good? Any questions? Please ask. If you're finding it fast, please let me know. I mean, every time I say this and I just continue, but please let me know. Okay? Now, how do I get 1 over 1 plus x squared from this? I have 1 over 1 plus a. Do you agree with this formula or not? Now, I want 1 over 1 plus x squared. What do you have to replace? How do you make it look like? How do you make 1 over 1 plus a look like 1 over 1 plus x squared? Replace a by x squared. Under what condition? Less than 1. Very good. One over 1 plus x squared is hence equal to sum when we start n equals 0 to infinity. What is that? What is that? Minus 1 n. Replace a by x squared to the n, provided that my a is strictly less than 1 in absolute value. So provided that the absolute value of x squared is strictly less than 1. Now the absolute value of x squared is strictly less than 1 if and only if the absolute value of x is strictly less than 1, right? This is equivalent to. Okay, well I have this now. How do I get arctan? I have a series of 1 over 1 plus x squared. How do I get the series of arctan? I integrate both sides of the equation. is equal to what? How do I integrate this one? Could I do it immediately? Could I integrate immediately? Or do you want me to write the steps? Write the steps. Write the steps. Again, the good thing about this is that you don't have to memorize anything. You can just rederive everything. Now this theorem tells me that I can exchange the infinite sum with the integral. Okay, now how do I integrate this one? How do I integrate minus 1 to the n x to the 2n? Minus 1 to the n x to the 2n plus 1 over 2n plus 1 plus z, and this is arctan of x. How do you find the value of c? How do you find the value of c? Plug in a number. What's an easy number to plug in? 0. Let's plug in 0. For x equals 0, I get arctan of 0. What is the value of this series if x is equal to 0? Do I need to do hard stuff or it's easy? If x is equal to 0, what is the value of this series? 0 plus c. Now what is arctan of 0? Arctan of 0 is 0, so c is equal to. Okay, so arctan of x is equal to what? What did we say? Sum n equals 0 to plus infinity. What time is it?
30 minutes.
How many?
30.
30. Okay, that's good. Thanks. Agree or not? So far so good? Yeah? Any questions? Any questions? Okay. Now, if I tell you, if I ask you to find the value so what is f of x? F of x is equal to c0 plus c1 x minus a plus c2 and so on. Okay? Agreed? Let's plug in x equal a. What do you get? X equal a on both sides. What do you get on the first side? F of a. On the right hand side, what do you get? You get f of a is equal to c0. Agreed? X equal a here, what happens? 0. X equal a here, what happens? And so on. Right? You agree? Okay. Now differentiate. What do you get? C1 plus 2 C2 x minus a. Here I have to be 3x minus a cubed, so let's just write it. Plus the other one plus 3c3 x minus a squared. Plug in, I want f prime of a. What do you have to plug in on both sides? A. Plug in a. Plug x equal a. What do you get? This side, what you get? X equal a. What do you get? F prime of a. This side, what do you get? C1. Okay? Let's do the exercise another time. Differentiate once more. What is f double prime of x? Derivative of c1 is derivative of 2c2 times x minus a is 2c2, right? Plus, what's the derivative of 3c3 x minus a squared? Very good. I'll just write it this way. 3 times, well, it's 2, okay, so it's 3 times 2c3. Well, let me, it's 2 times 3c3, let's write it this way. X minus a plus dot, right? What is that double plug in x equal a? What do you get? So f double prime of e. Okay, should we differentiate 1/3 time or it's obvious now? Is it obvious? What is f triple prime of a? F triple prime of a, what is this equal to? 63. What is f4? Well, f triple prime is here. What is the fourth derivative of a? Fourth derivative of a, what do you get? Everybody? 24c4. Do you guys see this or not? Everybody, do you see this? You said you get 24c4? Do you see that? Should I repeat it? Great. So let me put a c4 here, okay? And keep track of your derivative. F double prime differentiate once more, so you get 4 times 3 plus 4, or you get 3 times 4. Here you get cubed, so here you get squared. Differentiate this once more, you get 2 times 3 times 4 times x minus a, right? Differentiate the fourth time, you get 2 times 3 times 4. So what's f4a? It's 2 times, oh here I have 4. And it's 2 times 3 times 4 times c4. So which is, what is 2 times 3 times 4? This is 4 factorial times c4. So really the nth derivative of f at a is just n factorial times c. Okay? This is the most, well, one of the most important theorems of calculus. Okay? Great. Let's do an example. Fine. Someone give me an integer, very large integer. Very large. A volunteer who hasn't spoken today. An integer. Very large integer. 90? 10k. Okay. Find f of 10,000 at 0. And f of x is equal to 1 over 1 minus x. Are you going to differentiate 10,000 times? No. So how are we going to do this? You do this by power series. So, yeah, okay. I can tell you an exam question, I will not give you 10,000. Because 10,000 you will know that you won't differentiate. I'll give you something smaller. Okay? For example, I can give you 3 or 4. But the idea is still not to differentiate. Because even if you differentiate 4 times, it's going to take you a while. Okay? The idea is that whatever way you take, you will get the right answer, provided you don't mess up your 4 derivatives. Okay? But the idea here is to use power series. So what is 1 over 1 minus x? This is an easy one, right? Does 0 lie in the interval of convergence of this one, of this series? 0, does it lie in this interval of convergence? Yes. So what is f 10,000 of 0? The 10th derivative of f at 0. What should you look at? The coefficient of what? Of fn at 0 is n factorial times cn. Right? What are your cn's here? They're all constant equal to 1. Now what is my n factorial here? 10,000. Right? You see that? So f 10,000 of 0 is just 10,000 factorial. We do one more? Let's see if we can do one more. I mean, I want to do something easy. Let's see if I can do something easy. Okay, we do something easier. Something easier. Is that clear or not, folks? Is it clear? Any questions on this? Okay, let's do one more. Find someone give me a number. Everybody, guys, someone give me a number. 9. How do we start? Do I differentiate 9 times? No. It's going to take a while, right? What's a good idea? Power series. What power series am I looking at? 1 over 1 minus x squared. What is this power series? I could use this one and plug in x squared for x, right? Provided that my x squared has absolute value less than 1. Or x squared because x squared is non-negative. X squared has absolute, x squared is strictly less than 1, right? Again, I'm sorry if I'm going a bit fast because this is cost material. Great. What am I looking at? What am I looking at? I want f9 of 0. So I'm looking at the coefficient of x to the 9, right? Do I have an x to the 9 here? Do I have an x to the 9? Let me write this down. What do I get? I get 1 plus x squared plus x4 plus x6 plus x8 plus xn. What's the 9th derivative of f at 0? What's the coefficient of x to the 9? It's 9 factorial times the coefficient of x to the 9. Isn't that right? What's the coefficient of x to the 9 here? 0. Did I expect this or not? Did we expect this? Was it expected? 1 over 1 minus x squared, what type of function is it? It's an even function. Differentiate an even function. What do you get? An odd function. What's the value of an odd function at 0? F prime of 0 is 0. F triple prime at 0 is 0. F fifth derivative at 0 is 0, right? We could expect this. Okay? So, the coefficient of x is 9. I will make sure you practice this. Is 0. So, f to the 9, 0 is 9 factorial times 0, which is 0. Okay? Should we do one more? What time is it? Okay, great. So have a good beginning of the week. I wanted to say have a good weekend, but I guess we're a bit far.